Assalamualaikum, Doctor.
Waalaikumsalam. How are you, brother?
Good, Alhamdulillah.
Okay, alhamdulillah. 1 more minute. It's 5 o'clock.
Actually, some of us today are returning to Kuantan campus.
Oh, so okay. We can do whatever we can do, brother. Can we start already 5 o'clock rather than waiting? What do you think, brother? Okay, let me get about okay. Okay, let me wait until about 30 participants come in. And depend how long is it now? 28. Oh, still not moving.
Assalamualaikum, Doctor.
Waalaikumsalam. How are you, sister?
Yes, I'm good, Alhamdulillah.
Alhamdulillah.
How are you?
Great, Alhamdulillah. Okay, I think we should start. Shall we, brothers, sisters? Okay, now exactly 30 participants. We should start. Assalamualaikum, brothers and sisters.
Waalaikumsalam.
Yeah. Let's start our day with the recitation of Kitab Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin arrahmanir rahim maliki yaumiddin iyyaka na'budu wa iyyaka nasta'in ihdinas siratal mustaqim siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. As usual, before we start, we have a brother to recite a dua for us. So we invite Brother Ustaz Ahmad Husaini. Brother Husaini, tafadhal Ustaz. Bismillah.
A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Allahumma nabi bil kitabi absarana washrah bihi sudurana wasih bihi abdanana waslik bihi alsinatina wa qawwi bihi jinanina wasra' bihi fahmina wa qawwi bihi azaimana بحولك وقوتك فإنه لا حول ولا قوة إلا بك يا أرحم الراحمين اللهم استودعناك ما علمتنا فردده إلينا عند حاجتنا إليه ولا تنسناه يا رب العالمين آمين آمين يا رب العالمين
Amin ya rabbal alamin. Shukran, Ustaz. All right, we have a new topic today. Okay, let's figure out. I somehow collect some data about the GPA of 2 students. Up to you to believe me or not. For the past 5 semesters, for this particular student, they had 3, 2.9, and then 2.7, 2.6, and 2.5. And maybe this is a brother. And then I have another data from sister. For the past 5 semesters, he had 3, 3.1, 3.3, 3.4, and the recent one, 3.6. What do you think this semester brother will get? Can you Can someone say a number? What?
2.4.
Maybe 4 flat, sir.
4 flat, brother.
Yes, maybe. He study hard.
2.4.
2.4. 2.4. Okay, I just put 2.4. How about sister?
3.8 or
3.8. Okay, I just take 3.8.
2.74. Sorry,
I take
for the brother.
3.8 first.
wow.
Okay, I take 3.8 first. I do not know how you get this number.
The average
Yeah, a
of the
good
5.
average. You see the pattern or the average? So you are really a fortune teller, right? Poor brother. Don't worry, brother. You will get 4 flat afterward, or maybe more than 4 if possible. Okay, what are we doing? What are we doing? Do you take that number using crystal ball? Do you? No, right?
No.
No, you have some
Forecasting.
forecasting. So we are doing forecast. What are we doing? Why do we have to do forecast? In any organizations, we have to do forecasts. Yeah. So you always hear in the newspaper, some people, the quarterly sales for the next 1 year, or the sales will improve by how much. I think you read a lot in newspaper by some companies, they're predicting sales of Apple, sales of phone, Samsung, and so on. So why do we have to do that? So what is a forecast anyway? You are actually predicting what will happen in the future. So how do you forecast? And forecast, we have short range, maybe between every minutes, daily, hourly, and 2 months. So this range from short range up to 2 months, we call it short range forecast. And then anything between 1 month to 2 months or to 12 months, this is referred as medium range forecast. Or another one, a longer period, anything more than 2 years, we call it long range forecast. Take note, this is just a forecast. If you do strategic management, they have a different definitions. Short-term strategy, medium-term strategy, long-term strategy, they have different definitions. Maybe short-term strategy between 1 year to 2 years, medium range between 2 to 5 years, anything longer than 5 years. If it is in strategic management, we consider that as long-term strategy, long range or long-term strategy. Okay, forecast. How do you do? And why do we have to do? So it is important for any organization to plan. How to plan? We are planning to the future. How do you plan? Or you just que sera. What will be, will be. No, you have to plan. As a good executive, you have to plan. So the success of any organizations depend on how good you as a manager or executive can anticipate or foresee the future and then develop the right strategy, what you should do for the organizations. How do you do that? Take crystal ball? You can. So you should forecast as accurate as possible. So how do you do that? You need certain logical method. So we use what we call scientific forecasting. Then we are going to go through this scientific method to help us to make good decisions or to make good forecasts. There is also a situation when these people may not like the small shop owner or this cafeteria, how do they make forecasts? Maybe they use their experience, they use their intuition. They use their intuition to make the forecast based on his personal judgment, based on his experience, intuitions, and maybe what other people advise him. Well, it worked for small organizations, but when it comes to complex organization, it may not work. Okay, so we are going to do quantitative methods of forecasting, since our course also say quantitative analysis, quantitative methods. So quantitative methods or statistical forecast method, we are using what you did just now. We are using historical data. So the method, we have certain assumption here. Quantitative methods, past information about the variable is available. That means we have data collected. Information can be quantified, normally numbers. And last one, you see the assumption that the pattern of the past will occur into the future. So what you did just now, you use pattern of the past, and then you are predicting the future. Another one, qualitative methods. There is a situation when you don't have data or difficult to collect data. Situation like this, there is no choice, but you have to use qualitative methods, which you will discuss towards the end of the topic. So qualitative or judgmental forecast is used when we don't have any data or you cannot get viable data. How to do forecast? There are several steps to do. Number one, select items or quantities to be forecast. So what does this mean? If you are in a business, what do you want to forecast? Sales, manpower, profit, or new outlet. You say you are making outlets here and there. You want to forecast how many outlets by year end. How many branches are you going to make? So what are the items you want to forecast? Then determine the time horizon. You want to do 1 year, 1 month, 2 years, every day or weekly. So determine the time horizon. And then select the method, which you are going to go through later, the right method or the suitable method to your organizations. And then collect some data or necessary data for the previous information, get some historical data, and then make the forecast. For our initial one, we are going to use what we call time series. What is time series? Historical data to forecast the future. I mean, we have data with a certain periodic period. That means a certain point of time, like monthly, weekly, or quarterly, yearly. That means we have some data that has a certain periodical informations. And this this is referred as what we call time series. This historical data become what we refer as time series. And then a time series is a set of observations of a variable measured in a successive point in time over a successive period of time. Then why we do need to do all these 3 steps? where the purpose is to make a very accurate forecast or very, very good forecast so that you have some fair estimate about what you are going to perform in the future. And all this, we refer this as time series method. Okay, now look at what is time series, or how the information behave, the behavior or data. Let's look into the first one. We call it trend. What's trend? Something, if you collect data, say you have a variable here, the vertical axis, a variable, say sales data, profit data, or manpower, and so on. We collect the data. There is some pattern like this, up and down over time. And you see there's like some pattern going upward. We refer this as time series. That means the data gradually increase or decrease, the pattern going up and downward, but not very significantly up, not very significantly down. So we refer this as trend. And then the next one, what do you call this? Cyclical or cyclical. How do you pronounce this? I like to pronounce as cyclical, but you all like cyclical. Why cyclical? I think in maths, you know, when we collect data, the pattern somehow shaped like sinusoidal over time, going up, down, and then in future it repeats. It repeats. When it repeats, we refer this as cyclical. The data recurring sequence of points repeated after a certain number of periods over a span of time. Okay. When's the best time to sell cookies? Now? No, are you there? When's the best time to sell cookies?
In some occasions, I guess.
Yeah, next month, right? Another month we are going to have Ramadan.
Yeah.
Yes.
Yeah. So there is another one, we call it seasonal. Seasonal forecast. So things, sales like just now I did mention, selling cookies, the best time is late Ramadan or before Hari Raya. If you are in, say, temperate climate, when is the best time to sell winter clothing, summer clothing, or when is the best time to sell a ski product? I mean, during summertime. When are you going to, when's the best time to sell a winter coat or this? So this is seasonal, where the data is influenced by seasons. So we have a variable here, can be anything here. The variable could be a product. Just now I did give an example, ski product, winter clothing, cookies over time. So the pattern, let's say, is quarterly. The first quarter is low, second quarter high, third quarter very high, and then the fourth quarter come down again. Then the subsequent year, it repeat. The first quarter low, the second quarter go up, and so on. So the data varies due to seasonal influence. So data follow up and down periodically, but it repeat in every year. So this is seasonal data. Another one is random. Random data where there is no pattern at all. Random or irregular. For our purpose, we assume we cannot develop any mathematical equation on this one. So we assume it is random and irregular. We cannot develop any model from here. But we are doing advanced statistic, of course, you can develop here. For our purpose, assume we don't. The occurrence of data is totally unpredictable or having random variability. So it does not follow any pattern, or we call it irregular. Okay, let's look at the forecast methods. What are the methods? Quantitative and qualitative. Quantitative, we need data. Qualitative, we don't depend on data. So qualitative, one of the method, we call it Delphi techniques. There are other methods we will discuss later. Quantitative techniques or quantitative methods, we have causal and time series. Just now when you predict brother's performance for the semester, you use time series. You look at the past pattern and you predict. Causal, maybe brother, just now one brother mentioned brother can get 4 because he studied hard. That's causal method. Maybe brother start thinking if he were to spend 1 hour study, I think his GPA will increase by 0.5. If he spend 2 hours study, maybe his GPA will increase by maybe 1.5. If he spend 3 hours study, GPA will increase by so much. So brother will study 24 hours and then he get GPA 5. Possible, brother?
No,
Maximum.
not possible.
No, not possible. So this one we are going to use regression method. Time series, we use trend, smoothing method, and seasonal. And then exponential, we are going to use, smoothing, we are going to use what we call exponential method, and moving average method. And then moving average, we have simple moving average, weighted moving average. Weighted, how to pronounce this? Weighted. What is this one? Weighted. It's different, right? So my English is not so good. So I put, yeah, say weighted, I mean this one. Okay, smoothing methods. Let's say sales over time. We collect this data. Now you want to forecast for the future. Are you going to use this jagged number up? Let's say connect this one. Then you see the pattern up and down, up and down, up and down. And then are you going to take out this copy, paste to make your forecast? Are you going to do that?
No,
You
sir.
cannot. No, you cannot develop anything. So you don't want that. So you smooth it out. So you smooth out the data so that you can develop some form of mathematical models from here. So the objective of smoothing methods is to smooth out the random fluctuations caused by these irregular components of the time series. The data are relatively stable over time, applicable only when the time series does not have any clear trend or seasonal influences. Okay, let's look into moving average. We are going to do this afterwards. Simple moving average and weighted moving average. Then another one, exponential moving average, or we call it exponential smoothing. We try to smooth out, exponential smoothing. Right, simple moving average. We are going to use what the last or the most recent data values in the time series to forecast for the next period. Okay, let me intimidate you with this formula, very simple formula. Moving average is the sum of most recent n number of data values divided by n, or moving average for the next period n plus 1, sum of d over n. You are very good on memorizing formula. No need to be so worried about this. Okay, let's play it out. Let's look into this gasoline sales. Let's say we have a record of the last 12 weeks sale. The last 12 weeks. And this is the information we have. The first week, that means the first week means 12 weeks ago. The week number 12 is the most recent. So 12 weeks ago, I mean record number 1, it shows 17,000 gallons sold. And then week number 2, 21, 19, until week number 12, we have 22,000 gallons. Now your job is, you want to make a forecast for week number 13. So what will be the forecast for week number 13? How do we do that? Remember the formula just now, sum of most recent data. So what are the most recent data? The most recent data will be the last few. Why are we using the most recent set of data? The assumption is that the older data is almost obsolete or maybe a little bit outdated. And then the most recent data are more reliable and dependable and more current. So for our example, let's say we take n equals 3. If n is 3, what are we going to do? We take the last 3 data, 1, 2, 3. So n is 3. What was the formula just now? Sum of n data divided by n. Okay, let's make the forecast for week number 13. What was the formula again? Sum of data.
Sum of recent data divided by n.
N. So let's say n equals to 3. So we have 3. We take the last 3 divided by 3. We take the last 3, 22, 15, 20, add them together, divide by 3, you get 19. So you have your forecast 19. At the end of the week, at the end of week 13, that's your forecast when you are in week number 12. You are in week number 12, you make a forecast for week number 13, and this is your forecast, 19. And then at the end of the week, you get actual information. Your actual sales turn out to be 18,000 gallons. So what does this mean? Are we a bad forecaster?
No.
No, yeah, no. Since this is a forecast, this is real. Any difference?
Yes,
What's the
one
difference?
difference.
Short of 1,000. Short of. So these deviations, this difference, or we call it deviations, in forecast, we call it, in our terminology, we call it forecast error. It is not a mistake. Not to relate error as a mistake. It is referred as forecast error. What is the forecast error here? Short or more compared to our forecast? Short. So the forecast error is actual data minus forecast data. That means we have less 1,000 gallon compared to our forecast, right? Then we want to know how accurate is our forecast. So we are going to measure the forecast accuracy. Forecast accuracy is measured by calculating the average sum of the squared error, or we call it mean squared error. Okay. What does this mean? Okay, let's look at the set of data. Let's say this is the same set of data, week 1 to 12. This is the actual record that we display just now. Let's say on week number 3, they make a forecast for week number 4. So this is the forecast for week number 4, 19. At the end of week number 4, this is the actual sales, 23. So that's a deviation of 4. And it goes on when you are in week number 4, you make a forecast for week number 5. So this is your forecast, 21. At the end of week number 5, this is your actual data, and so on until week number 13. And you have these deviations. We call it forecast error. If you add this together, you have to take the average of this. You can't, because you will cancel each other, the negative numbers. So you square this to eliminate the number. I think you are aware of this in our statistic. Then these are the squared number. 4 squared, 16, negative 3 squared, 9, negative 4 squared, 16. And add all this together, we have 92. Just now, what did we say? MSE, mean squared error. Mean means the average. So 92 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, let's see the mean squared error. This is the mean squared error, 10.22. All right, done with one method, simple moving average. Let's look at another one, weighted moving average. What does this mean? So you are good at memorizing formula. Weighted moving average for the next period, n is the current period, plus 1 for the next period, equal to sum of weight times d. D what? What's d? Data. So what does this mean? Let's say we have sets of data. Let's say this is set of data number 1, number 2, number 3, number 4, number 5. Say we have 5 sets of data. And then we feel that the most recent data are most reliable. Then we try to allocate, let's say here 1, 2, 3. And 1, 2, 3 equals 6. So let's find a fraction of this. So the last data, maybe the weightage is 3 out of 6. So 0.5, let's say. Then the second last, we allocate say 2. Say 2 over 6. Say 1/3, 0.333. Here, of course, 0.17. So let's say this is for illustration purpose, we use this weightage. The most recent, we allocate 0.5. Something before it, 0.33. And the older one, 0.17. So let's just look into 3, n equals to 3 for discussion purpose. You can have more than 3 if you like, but for illustration we use 3. Let's look into this example also, the same example. So at week number 3, we are making forecast for week number 4. How do you do just now? Weight, sum of weight times What's the forecast again? Sum of weight times data. Remember? Yeah, you remember. So what is the weight? For the most recent, we are going to look at the most recent here. The most recent, because we are at week number 3. The most recent is 19. So we use 19 times the weight. Just now we assign 0.5. Then the previous one, 21. Yeah, 21. Then we assign the weightage 0.33. Then the oldest one, 17. We assign weight of this one. So we add this together, sum of weight times D. Sum of weight times D. Weight times D. Sum is add together. So we have 19.32. We do the same when you are week number 4. At the end of the week, you get this 23. Your forecast is 19. So at week number 4, you are making a forecast for week number 5. And you do the same computations. This is your forecast. At the end of week number 5, this is your actual sales, 18. And you go on until you reach week 13. You repeat this process. Let me take the latest here. Here, when you are week number 4, you are using the latest is 23. So this 23. Then the next latest 19. The next one is 21. And it roll down. So this is your forecast for week number 13, 19.35. Okay. So the same thing, we are going to calculate the forecast error. Forecast error. You take the error here. What's the error again? Actual minus forecast. Actual minus forecast. Actual minus forecast. So these are the error. Square it. We get, then we take the average. We call it mean. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 103.29 divided by 9. So this is what you get. 103.29 divided by 9, 11.48. Okay, what happened? Now between the two, you see if we use moving average, the mean squared error is 10.22. Using weighted moving average, the mean square error is 11.48. This one less. So it look like using simple moving average is better than weighted moving average. It look like, but not necessarily. Not necessarily simple moving average is better than weighted moving average. It all depends on the data set. So sometimes if you use a different set of data, the weighted moving average will generate less mean squared error. Okay, we have done, just now we have 3 weights. Remember that we are going to use we use 3 weight, but this time you do not want to calculate 3 weight. Instead, 1 will do. We call it exponential smoothing. So in this case, we use the weighted average of the past time series. And then we want to select only 1 weight. 1 weight, 1 factor. It means we are going to put 1 weight based on the most recent observations. Here, the concept here, the weights of the other data values are computed automatically, and it will get smaller and smaller as it goes away from the recent data. So and then you notice that the word exponential. I think you know what is exponential. Exponential is exponential. Exponential is something like that, right? What it means here, we are going to take a certain value of weight here. I mean, as it go to the past, this weight getting smaller and smaller and smaller and smaller. This is what it means. By virtue of the mathematical equations, compute automatically and get smaller and smaller as it move away from the recent data. Okay, let's play with it. This is the formula for exponential smoothing. F is the forecast for the current period T plus 1. That means we are making forecast for the next period equals alpha times YT, not my white cat. T is the current data, plus 1 minus alpha times the forecast of the current period. Take note. So we are going to use alpha. Alpha is actually the smoothing constant, we call it. The smoothing constant. Okay. Same set of data. Put here, up here, the formula. You can see the formula here. So alpha forecast, you like the forecast. Now you are in period T, period 1. Forecast, you are in period number 1. Ft plus 1, you are making forecast for T plus 1. T is 1. 1 plus 1, we are making forecast for the next period. That means we are making forecast for week number 2. And then assume we are given the smoothing constant 0.2. YT is the current data. This is the current data. And then FT is the forecast data. So when you want to make a forecast for the next period, you need alpha times, you are now in week 1. You don't have this information yet. You are in week number 1. What is alpha? 0.2.
0.2 times 7.
17. Then plus 1 minus alpha times what? We don't have the data. First week. So we don't have this data. No data. What are we going to do? We assume. This is the same. That means we assume the forecast data is the same for this one. Okay, you see the pattern. Ft plus 1, that means forecast for the next period, equal forecast, alpha times current data, actual data, plus 1 minus alpha, current forecast data, 17. Take note. So alpha 0.2, 1 minus alpha is 0.8, 1 alpha times YT, this is YT, 17, plus 1 minus alpha, 0.8, times FT, this is the current forecast. And then at the end of week 2, you collect the data, you have 21 as your actual data. So this is your actual one. Then you repeat the process. So you repeat the process. Now you want to make a forecast for period number 3. Now you are in week number 2. You want to make a forecast for period number 3. So the same thing, you are using 0.2 times What did I say? YT, current data, and then 0.8, 1 minus alpha times forecast data. This is the forecast data. And this is what you get. And you repeat the process and you manage to forecast until week 13. This is your forecast, 19.8. So this is the way we do. Then we find the forecast error, the same method. Here we find the error and then square it, then divide by the number of occurrence here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 98.8 divided by 11. So this is your forecast, your mean squared error. Okay. Any questions so far? No question? Okay. If I were to rewrite this, can I rewrite this one? Alpha YT plus FT minus alpha FT. Agree? If I were to rewrite this way? Yes.
Yes.
Yes. Okay. Now let me put another pattern another way. FT plus, I put a common factor here, alpha, alpha. I put alpha here and YT minus FT. Is it the same? The same set of equations, right?
Yes.
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 So this is this is what is it? You notice the one in bracket here, YT minus FT, actual data minus forecast. What is it?
Error.
Error. So this is actually forecast error. Any questions? No questions. No question. I move on. Let's find what is the best value of alpha using this smoothing constant. What is the best value of this alpha or the smoothing constant? So what you do, you try out maybe 0.1, 0.2 of alpha, 0.3, 0.4, 0.5, 0.6 until 1. You try all this and then calculate the mean squared error. Okay, let's say already done. So here, if the time series is stable, higher value of alpha is better. If not, then it is better to use lower value of alpha. So as I said, you can find by trial and error. In our case, let's say it's already done. If alpha is 0.1, 0.2, 0.3 here on the left-hand column, if I were to calculate using this value and then calculate the mean squared error, these are the mean squared error. Now we look at the lowest squared error. What is the best value of alpha in our case? Which one generate the least error? I shouldn't put green color there. What's the best value? 0.2. Is it because of green color or you look at this number? You let this number is the lowest, right? 8.98 is the lowest amongst all. So if we use 0.2, it will generate the least error. So this is a summary using the simple moving average, weighted moving average, exponential smoothing using alpha 0.2. Your mean squared error 10.22, 11.48. and 8.98. Okay, take a break. Can we take a break for a few minutes?
Sure, doctor.
Yes.
Okay, take a break for 1 minute while you digest, and I am on standby. You have any query? Say I give you 3 minutes break. I think 3 minutes is
Okay, sir.
sufficient. And then you can have some drink. Those are still online. Any question? You are not taking any rest?
Doctor, I want to ask.
Yeah.
So for the moving average,
Mhm.
the n must what is the minimum n we should use? For example, you use 3, right?
The best is 3. It can be 3. It can be 5. It depends on the organization's estimate. If you have a lot of data, if the data is quite frequent, we use more than 3 is okay. But if the data is say weekly, considered not so frequent, I mean maybe 4 or sufficient. Some use 5. There are also situations you can have more than 5. More than 5. There is no rule. It says that must be 3 better, 5 better. It also depends on the pattern of the data. If the data pattern somehow it fluctuates a lot, then it's better to have higher number of n. Do I answer you, brother? Yeah.
Yes, sir. Thank you. Doctor,
Welcome.
someone asked something in the chat.
Oh, let's check. What does he ask? Where is it? What's the questions in the chat? Cannot find. What's the question? Can you just say it out?
Want to see the calculation for the previous slide.
Which one? This one?
Calculation for alpha.
This one? Some more? This one? Is it this one? This one, brother? The calculation? This is the calculation. Okay. Is it this one? This one, the same thing. So we are using 23, 23, and 18. This is your FT. This is your Y4. Let me Y4, F4. Now you want to make forecast for week 5. So what you do is 0.2, times 23 plus 0.8 times this is 18.0, 18.04, and you get this one. Similarly, when you have at the end of week 6, you have this data 16. Then you're already here. Now you want to make forecast for week 7. You have YT, Y6, you have F6. You are making forecast FT plus 1. That means F7. We are making forecast for F7. The formula FT plus 1. That means you are making a forecast plus 1, making a forecast for the next period. Are you okay? And this is Y6, F6. So you are making a forecast for this one. So how do you do? 0.2 times what? Not 20, 16. 16 plus 0.8 times
18.83.
18.83, yes. 83. Then you get this one. All right. This one, you have to look left, right, left, right, left, right, left, right, and until you get this one. All right. Can I move on? We have some time.
Sure.
Move on. Okay, let's move on. Bismillah. Let's look into another one. Trend time series, trend line or trend projections. In trend projection, we are going to find the trend. What does it mean? Find the trend. We are going to find the equation, the trend equation or the linear equations, and then project the trend into the future. Situation like this applicable when the data value is almost consistent, slightly increase, slight decrease over a period of time. So we refer this as linear trend line projections. If we look into statistics, we are using the least square method or least square regression method. Okay, what is it? What does it mean? This is what time series trend. So we have a data up, down, a little bit, a nice pattern. Then we can approximate into a straight line. When we can approximate this into straight line, let's recall about our school mathematics. Remember our school maths? Y, what's this one?
MX plus C.
Mx plus C, yes. Can I rewrite this one? C plus Mx. What is C?
The Y intersection.
Y intercept here. Where's M? The
Gradient.
The gradient or the slope. So this is M. Okay, let's say now we use different notations. We use T as we refer as trend, and here the period small t or lowercase t. And now let's use a different notations for our purpose. Here the intercept instead of C, let me use B0. And then the gradient instead of M, I rewrite as B1. If I were to rewrite these equations, T for period T, this is the period T, the equal B0 or B0 plus B1 T. Do you agree?
Yes, sir.
Yes, it's the same. So it was a simple thing, simple mathematics, but let's see how. So this is the linear trend we are going to find. So when we want to do forecast, what we do, we are going to find this linear trend, the linear equations for the set of data. What we are going to do, find B1 and then find B0. So B0, the intercept, you agree just now. B1 is the gradient or the slope. Huh. So to find B1, this is the set of formula. B1, sum of T, the period T, YT, the data, minus sum of T, the period, sum of data, YT, divided by the number of data, N, divided by sum of T squared, minus sum of T squared over N. Just find B0, B1, and then find B0, which is mean Y, the mean Y minus B1T. I think you know what is mean Y, sum of Y divided by N, mean T, sum of T divided by N. N is the number of observations. Mean T. What is this one? We are not going to have T. So we are having mean T, not mean T. Okay, let's operationalize it. Trend projections. Let's say we are having bicycle sales for the past 10 years. These are the period T, year 1, year 2 until year 10. Let's represent it as T. Let's say the sales data for each year Y T is the period Y1 21.6 thousand, year Y2, Y3, and until the year 10. Now we are going to find the trend equations. You remember the formula just now? So we are going to make forecast for year 11, year 12, year 13. Let's try. So what we do is find, you want to apply at the formula, right? Here, we are going to apply this. What do you need to have is all this sum of T, sum of YT, sum of TYT, sum of T squared. Okay, let's see how we do. So you find the sum of T, 1 plus 2 plus 3 plus 4 plus 5, you get 55. Sum of T, these are the data. Sum it up, you have sum of YT, this one. Sum of TYT, that means 1 times 21.6, 21.6, 2 times 22.9, 45.8, 3 times 25.5, 76.5, and add it up, you have sum of T times YT, sum of TYT, 1545, and then sum of T squared. So you square this number, T, 1 squared, you get 1, 2 squared, 4, 3 squared, 9, and so on. And then sum it up, you get this number. And then, what do?
Put them in the equation and
Put in
find
the
B1,
equation.
B0.
Yes. Put into these equations. When you put into this equation, into these equations, you will get B1 and B0. Okay, I don't go into detail. I think when we do the exercise, we will do into detail. And you will get these equations. Maybe you get B1, you get B1, this one B0. Okay, let's see. This is B1. In your computation, you get B1, or you want to try B0. And this is your equations. Now the question is, can you make a forecast for T11? Can you make a forecast for T11? Of course you can. 20.4
Yes.
plus 1.1,
1.1 times 11.
11. So easy. So now, can we make a forecast for year 11, year 12, year 13?
Yes,
Can we? Yes. So you can make a forecast for the next period. Okay, right? The next period, let me see, year 11. You can make the forecast somewhere here. Say is the forecast for next period. You can also make a forecast beyond the next period. You can make a forecast for period year 11, year 15, year 20, if you wish, and so on. Compared to the earlier one, which we did, we can only forecast only up to the next period, not more. But using trend, you can make a forecast far beyond the next period. Okay, again, what is this B1? Where's B1? Remember just now in our schoolwork?
B1 is the gradient.
The gradient. So that means if I have something like that, for every year, the gradient for here 1 year. What's the number here? Every year there is an increase of this one, right?
1.1, yes.
1.1. So every year there is an increase of 1.1. If I were to ask you the question, what's the average increase of the sales for the past 10 years? Can you answer me? Do you need a special calculator to do? No need. Here, this is the answer. Every year, there's an increase of 1.1 thousand, because it's in thousand times 1,000. So the slope represents the average increase over the past 10 years. So this is what it means. The slope represents this increase. Right? And this is what we have done. If we were to do some projections, if we were to substitute this T equals 11, this is your forecast. If T is 12, this is your forecast. You can play around. T16, you can try out if you like to. You can easily calculate. Okay. Any question? No question.
Master,
No. Good.
for B1,
Yeah.
the formula divided by n is only for 1, right? I mean,
Which one? The formula.
The formula for B1.
Uh-huh.
So
B1 is given the formula for B1 equal to sum of T YT minus sum of T times sum of YT over N, and the whole thing divided by sum of T squared minus sum of T whole thing squared. It's not the T squared, the sum squared divided by N. And then B0, we need B1 equals to Y bar minus B1 that we get from here, B1 T, what is T bar, Y bar? Mean Y, mean T. Are you with me? So
yes, sir.
that's why when we encounter situation like this, we need this sum of YT. So find sum of T, sum of YT. And then we already get this one, this one. This one we can use this one. This one sum of this one. And you can calculate a number of observations. Here you have to find, you calculate sum of T squared. And then here sum of T, you already sum of here sum of T. You can here you have this number sum of T square it. This number whole thing square it for this one. I circle here. Then after getting B1, after getting B1 only, you can find B0. After this one, you can find B0. Y bar, of course, you know total Y divided by N. And then T bar, total T divided by N. All right. Okay. Is it a lot already?
Okay, sir.
Okay. I think you are all very energetic person. Okay, let's move. Since we have time, I move to one more. I think this one take a little while only. What if we have some quarterly sales? That means seasonal sales or seasonal information. What are you going to do? Just now we did trend, we have done trend. Now we are working on seasonal. So I show you the simple one first. Number one, calculate the seasonal factor. And then we are going to add up the total sales, make forecasts using trend, and then make it into seasonal again. Okay, how do we do that? Okay, let's play with it. Let's say you are given this turkey sale, turkey meat sale. Let's say this one year, the first year, this is every quarter, this is the sale. Quarter 1, 12.6, quarter 2, 8.6, quarter 3, 6.3, quarter 4, 17.5. Let's say, I do not know what number is this in the ton, the kilogram or what. Then the following year, say year number 2, quarter 1, 14.1, quarter 2, 10.3, quarter 3, 7.5, quarter 4, 18.2. Similarly, year 3 is the quarterly sales. What are we going to do? So what we can do, we add up the yearly sales for each year. So we total up. You want to try? Test the first number, 12.6 plus 8.6, 21.2 plus 6.3, 27.5 plus 17.5. Can you calculate?
45.
45. The same thing for second one. The same thing for the third one. Add it up. Then we also add the quarterly. So find the total for each quarter. So each quarter for the past 3 years, we add it up. Okay, maybe you try first. 12.6 plus 14.1 plus 15.6. What do you get?
42.
42. The same thing here, 29. The same thing here, 21.9 over here, this one. And the total sales for the past 3 years will be 148. Now let's find the seasonal factor. I call it seasonal factor. Seasonal factor. Factor is a factor proportion. So we know the total sales. You know the quarter 1 sales, quarter 2 sales, quarter 3 sales, quarter 4 sales. Can we find the proportion of this? 42 out of? Can you say 42 out of 148? Are you with me?
0.28.
Yeah, the concept. Are you with me? That means this one, 0.28. Rather, already calculate 42 divided by 148. How about quarter 2? The same thing. 29.5 divided by 148.7. Anybody calculating?
0.2.
0.2. And then
0.15.
0.15. Okay, let me calculate for you. So these are what we call seasonal factors. But your job is to make forecast for period 4 or year 2006. So now what should we do? Now look at the total sales. We have 3 sets of data now. Let's find the trend. We use the trend using this data, 45, 50.1, this one. Let's say the trend, this is trend YT. Trend YT, trend YT, and then we have T1, period 1, period 2, period number 3. Using these informations, just now like what we do, find the sum of T, sum of YT, sum of T, YT, sum of T squared. Substitute in our equation just now, find B1, then B0. You will get an equations. We don't go through that. So you get these equations at the top here. So we have TT equals to 40.97. This is B0. This is B1. So this is B not B0. This is B1. Okay. Now, using these informations, we want to know what will be the forecast on period 4. Can we? So what do you do? Put T equal
To 4.
T equal to 4. As simple as that. So can we make a forecast for T4. So now we want to know what is the forecast for T4. Can we? T4. 58.17. You are done. So now we know the yearly sales for 2006 or year 4 is this one. Now your job is to find the quarterly sales. Quarterly sales. Quarter 1, quarter 2, quarter 3, and quarter 4. How do you do? Multiply this one with the factor. Multiply this factor. Just now we divide, right? But now we know the total sales for year 4. If we multiply with this factor, can we get a number? Can we?
Yes.
Yes. You get some number. Try.
16.29.
16.29. So this is the quarterly forecast for quarter 1 for year 2006. Year period 4. How about the next period for the second quarter forecast? Okay, I do for you. You want to try? Better try. 0.15 times 58.17.
8.73.
8.73. And the last one, maybe give it one try. Done, right? You get this number? Yes. So this is your, okay. So this is your quarterly forecast for period 4. For period 4. So this is quite an easy method. So I think next class we try to do another method to make quarterly forecast. And it will be more exciting than this one. All right. I think we are done for the day. Any questions? No question. We cover a lot today. In a proper class, normally I don't cover the seasonal forecast during the first meeting. If none, can I end our session today?
Yes.
Yeah.
Sure, Doctor.
Sure. 1 minute. Why I cannot activate this one? All right. No questions. If no questions, then let's end our day with the recitation of Suratul Nas. Bismillahirrahmanirrahim. Wa as inna insani lafi lalazina amanu. Thank you very much, brothers and sisters. See you next class, Wednesday.
Thank you, Doctor.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
You're most welcome.
Thank you.
Most welcome. Welcome.
Thank you, Doctor.
Welcome.
Thank you, sir.
Most welcome. So I end now.
Thank you, Doctor.
Yeah, welcome. So I'm ending the class now.